So in order to understand integration, we need to recap differentiation. So I'm going to use a few slides again, and we can just take what you need from here. I'll send this once we've covered this section, because this is the last bit of extra note that we need to use. Okay, so remember what is the purpose of a derivative? Let's just recap that theory, because if you can understand that, it's easy to understand integration. What is the purpose of the derivative?
Just simplify so to get
It's to get a
derivative of a function.
Yeah, it's to get a derivative, which is an expression that helps you to solve for certain things. Okay, so last week we looked at different ways of using the derivative to find a min or a max, to find the turning point, that type of thing. So when looking at differentiation, that's the process. That's how we derive a derivative. Okay, dy over dx is basically differentiating y in terms of x to get an expression. So if I had a function y equals x squared, the derivative would be 2x. That 2x is the derivative of the function. So if I've got integration, it's the complete opposite. So when looking at derivatives, you're going to be taking what you have and you're going to be reversing it out. Okay, so did I put that table? Yes, I did. Right, so when looking at this differentiation, do we make the expressions simple, well, let's say more simple or more complex?
More complex. No, more simple.
More simple. Hey, do you agree? If I've got x squared, okay, a squared is more complex or slightly more complex than 2x. Okay, 2x is simple, right? 2 times x, no square. So that would be the derivative. So now, is it possible to go backwards? I.e., if I've got the derivative, can I go back to the function? And of course you can. Okay, if you do the one, you can go back to the other. So that's what integration is looking at. The integration is doing the opposite, the complete opposite. So what do we do when we find a derivative? Well, if we look at this, if I've got 3 as the power, okay, the derivative would be what? 3x squared. So I'll multiply that and I minus 1 from the exponent. Okay, so you should be getting there quite easily, right? For the 3x squared. So now if I've got 3x squared and I know that's the derivative, is it possible to get from the derivative back to the function? Okay, and obviously the function would be x to the 3. Okay, it doesn't matter what constant I have. So for example, if I had x to the 3 here plus 1, what would the derivative be?
3x squared.
Exactly. If I had x to the 3 plus 10, what would the derivative be?
3x squared.
Exactly. Okay, so do you agree? It doesn't matter what the constant is. The constants fall away when you have a derivative. So when doing integration, you're going backwards. Okay, you're taking what you started with and you're moving one step back. Right, so if I'm looking at this, this is the fancy notation that like almost like a curved F is the notation that's used for derivative. So if I have that would be the derivative, and I'm moving back to a function. Okay, so how do we actually apply that? Well, remember earlier I showed you the derivative of 2x. Okay, so we know that the function of 2x is x squared. Okay, but the thing is, we need to follow the integration rule or process in order to get there. So what must you do with the actual derivative? Well, you need to add 1 to the exponent, and then you divide the entire thing by that exponent. And then that's what you do. Okay, that's the process. Right, so in order to go back from derivative to function, you just have to apply that process. You add 1 to the exponent and you write down that exponent expression over the term. That's all. And then you add c. Why do you add c? Because of this. Any constant that's derived gives you 0. Okay, so it could be plus c, it could be any c. Okay, it could be 1,000,000, it could be 500, it could be 10, it could be 0,5. It doesn't matter what it is, it'll still
cancel out.
Well, yeah, basically land up at 0, fall away, exactly. Okay, good. Right, so what am I going to do with 2x? Well, what do I have here? I have a 2 and I have an x. What is the power of x if there is no written number? It's 1, right? Okay, so there's an invisible 1 there. So what does the rule say? The rule says write down your x to the n, add 1. So there, write down your x to the n,
so the n
add
is the
1.
exponent.
Yeah, n plus 1 is the exponent. And then divided by that expression, that exponent. 1 plus 1.
So this denominator will always be the same as this.
It'll always be exactly the same.
Okay.
Exactly the same. Okay, that's just how you do it. It's like there's a rule to go from the function to the derivative, and we use differentiation. Now here's the rule to go from the derivative to the function. That's all. It's just opposite. Okay, so what do I have left after I've done this? Well, do you agree 2x to the 2 over 2 plus c is what? Cancel, cancel. And then I'm left with that. Okay, so there's the function. Okay, but the function comes from the derivative. Okay, that's the integration. That's the process that you're doing. Okay, so integration is just that. It's taking an expression and make it more complex. Okay, it's making it bigger. It's getting you to the function, basically, if you have a derivative. Right, so that's how you do it. Okay, that's something that you need to write down. So just to write down a theory, bullet number 1, you can say integration is the opposite of differentiation. Okay, second bullet, derivative back to function. Well, inverted commas function. It's not always called a function. It's just called an expression that helps you to do certain calculations. Okay, so we'll see how we apply integration later. I see they do give you one application. Okay. Right, that's great. And you can just write down this formula. Just wrap out the red. That formula there. And that's the thing that you would have to study. Right, you don't really have to study it if you just do enough examples. Okay, but obviously to start off, we'll be using it. And that's the complete opposite to integration. Okay. Yeah, it's a plus. N plus 1, n plus 1.
Yeah.
Okay, the plus c is just randomly put there. Why? Because any constant falls away. Right, so let's go back and let's look at some of these examples. Okay, so I've done it this way just to show you the process, because if you can understand going forward, you should be able to understand going backwards. Right, so let's start by talking about the derivative. What is the derivative of y equals 4x to the 3? What would the dy over dx be?
4, okay, so it will be 3 times 4 is 12, x to the 2.
Correct. Okay, so what have you done? You've done the derivatives. You did last week's stuff. Okay, today you're looking at integration, which is the opposite. Okay, so what am I going to do with integration? I'm going to integrate, okay, that expression in terms of x. Okay, that's what I'm going to do. Right, so what am I going to do? I'm going to write down the 12. I'm going to write down the x. Okay, then what does the integration say? Write down the expression, exponent plus 1 all over 2 plus 1. Okay, plus c equals. Right, so now what do I have here? What's 2 plus 1?
3.
Exactly. So 12 x to the 3 over 3 plus c gives you what? Cancel, cancel, gives you 4 x to the 3 plus c. That's how
do you always have to write plus c even if there's no c?
Correct. Yeah, c will have a value if they give you enough information. Okay, so
can I also
there's
do
the
this
first one.
table?
Yeah, of course. Right, so what are we doing? We're just going backwards. Okay, and that's why I've done it this way, just to show you that if you've got a function, you can work out the derivative. If you've got the derivative, you can get the function. It doesn't really matter. Okay, you know the answer is going to be what we started with, which was 4x to the 3, right? Okay, so we've gone through the whole process. Take the function to the derivative, take the derivative back to the function. And that's what we're doing here. See, they even give you the same thing, that's good. They use the same formula here. Okay, same general equation.
Function.
Yeah, you might need a bigger table because we're going to do quite a few. So you can just extend it if you need to. Makes sense?
Yeah.
Okay. Right, so the first one is y equals 4x to the 3. So even in the work program they say never forget the arbitrary constants. Okay, the constants is there because any constant will fall away. So it could be anything actually. Right, okay, the first one's complete, great. Let's look at another one. Okay, so obviously step number 1 is to do what? Get the question. Okay, but we're getting the question by doing the derivative. Okay, so what is the derivative of 2x5 dy over dx, which would denote the derivative, is going to be what?
Okay, so let me just write this down. So it's 10x to the 4.
Exactly. Okay, so if we were doing integration, we would be starting with this, integrate 10x to the 4, and that'll equal. Okay, so again, what is the rule? Write down the constant, okay, or the coefficient of the expression, that stays the same. X to the 4 plus 1. And then all over 4 plus 1. Right, plus C. Okay, so then I've got 10 x to the 5 over 5 plus C equals 2 x to the 5 plus c. Easy, right? Okay. Let's do another. Derivative of that.
Okay, let me just write this down. 2x to the minus. Okay, so it'll be minus 6.
Yes.
Minus 6. Minus 3 minus 1 is minus 2.
Minus 3 minus 1 is?
Minus 4.
Yeah. Okay. Right, so then next step.
So minus 6x.
Yeah, so integrate minus 6x minus 4. Right, so what am I going to do? Write down the minus 6. Write down the x to the minus 4. What do? I add 1 and I write down the minus 4 plus 1 at the denominator. Okay, same rule applies. Nothing changes. Okay, so what is minus 4 plus 1? Minus 3. Okay, so minus 6 over minus 3 .
What about the exponent for the 6?
Exponent for the 6. No, there is no exponent for the 6. The 6 is the 6. The 6 stays on its own. That stays on its own.
Because like here we said 10x to the 5 and now we're saying minus 6. It mustn't be minus 6x to the minus.
Oh, well then you can just write it on the top there.
Yeah.
That's all. Yeah, it will be the same thing. You can write down this x to the 5 next to the number on the top, or you can write it as an expression on its own. It's the same thing. Okay, what does that give you? 2, x to the minus 3. Okay, so this can be simplified to this.
Very cool.
Okay, do you want to try the next one yourself?
Yeah.
Let's see. Can you do it? Yes, obviously derivative first, just to practice that. Ooh, be careful here. I wrote dy over dx, that's not right. You don't have y and x, you have s and t. So notation wise it would be ds over dt. Okay, so ds over dt would be what?
Okay, so it'll be 5 times 6. So it'll be 5 times 6 is 30 t to 4.
Yeah, that's it. Okay, so then you would integrate 30t to the 4 dt. Okay, what would that integration answer be? Okay, obviously it will be 6t to the 5, but we need the middle step.
30 t 4 minus 1.
Not minus 1.
4 plus 1 I mean. Over 4 plus 1. plus c equals 2 50t 5 over 5 plus c equals 2. 6x to the 5.
6t, yeah.
6t.
6t to the power 5.
T 5 plus c.
See, that's how you do it. Okay, so it's the same process time and time again. Okay, what happens if you have this? Okay, it's a little bit different now. What happens if you have a 16?
Let me just complete this so I can concentrate. Okay.
Okay, well, let's first do the derivative, hey?
Yeah.
So, ds, or dy now, back to dy. dy over dx.
Okay, so y equals 16 plus x. Okay. So it will be 16 is the constant, isn't it? Yeah, so that falls away. So it will just be 2x to 2x.
Exactly, okay. Okay, and that's why the plus c is there, because the c could be anything.
Yeah. Okay. 2x. 2x equals 2. 2x. So it'll just be 1 plus 1.
Yeah.
1 plus c equals will it be x squared plus 16?
No, x squared plus c, because it's any constant.
No.
The constant doesn't matter. It could have been anything. Okay, the only reason why we've got 16 there is because it was given to us. Okay, but that's why going back, that's the next part that we haven't discussed yet, solving for c. Okay, it is possible to solve for c, but you need more information. Okay, let's try the last two. See if we can get those two.
Is this all you have to do for integration?
Yeah, that's it. Well, you need to apply it. Same thing with derivatives. Derivatives is derivatives. The thing is you can use it in different places. So we haven't looked at where do we use this yet. But at least we know how to do it.
Okay.
Okay, so we know how to integrate.
So minus 3 times minus 1 will be 3.
Yes.
3x to minus 4.
Yes, okay. Right, so integrate that. Integrate 3x to the minus 4 dx equals, well, write down the 3.
So it'll be minus x to the minus 3.
Yeah, Okay, minus x to the 3.
3, yeah.
Minus 3.
Yeah,
Minus
minus
3.
3. Yeah.
Minus 3. Minus x to the minus 3x. Well, to the x minus 3.
Yeah.
Okay, last time, what do we do? Dy over dx is
200 minus x minus 10.
Yeah, so the point is it doesn't matter what the constant is, the constant falls away. Okay,
No,
you can solve for it, but obviously we're not looking at it yet, okay?
Okay, so minus 10 times, oh no, yeah, it will just be, so we forget about that, so it's minus 10 times minus 1 will be 10. 10x to the 9. Oh, sorry, 11.
What's the rule?
11.
It's minus 10 minus 1, which is minus 11.
Okay. So 10x to the 9.
Okay.
X equals 2.
Integrate 10 x to the minus 11 dx equals, can we apply the rule, 10 minus 11 plus 1 over minus 11 plus 1 plus c. Okay, that gives me 10 x to the minus 9, minus 10 over minus 10 plus c. Okay, negative over negative, you cancel. Well, a positive over a negative, cancel the 10s, lands up with minus x to the minus 10 plus c. Right, and that's integration. Okay, so that's how you do it in terms of the process to get from the derivative to the function. Okay, we need the function because we can use it to do certain things. Okay, so that's the first step. That's what they had here. Okay, second step. Oh, maybe just one other thing. If you have something like this, maybe let's do one of these examples. Okay, before I look at that, let's go to blank paper. Okay, here's blank paper. We'll use this. Okay, so if I have something like this, what happens if they give you something that looks like this? F of x to the 9 plus 5x squared over x to the 5 dx. Alright, so this is something separate just to consider. We still use the same rule, but there's something that you need to do first. Okay, and we wrote the same thing for derivatives. Okay, with a derivative, what do we say we must always do? Simplify it, right? Get it in the right format. Once it's in the right format, then you can apply the rule. Okay, the same thing applies to integration. So if I have something like this, what must I do? Can I integrate looking at that term as is? No, there's no way you can integrate x9 plus 5x squared over x5 in one go.
Because it's not in the right format.
Because it's not in the right format, exactly.
Okay, so just write this down.
Okay, so you need to get it in the right format. The format is as follows. Here. That's the format. You need to get something that looks like this. Okay, in its simplest form. Right, so in other words, x to the power something. X to the power something can be integrated using this formula. Okay, so if I have it in the simple format, then I can apply this rule. Okay, so let's go back.
Can I just go back to the Yeah, can I just
yeah,
copy that
it's the same rule, but we're just obviously simplifying it first before we integrate.
Okay, cool.
Okay, so what are we going to do here? Get it in its simpler form. Okay, so if x to the 9 over 5, x to the 5, plus 5x squared over x to the 5 dx. Can I simplify those terms? Yes. So integrate. What is the rule when you have exponents? See, this is revision from your exponent stuff. Okay, if I have an exponent at the top and an exponent at the bottom, do I add or subtract?
Subtract.
Subtract, because you're obviously cancelling the 5 with the 9, in other words. Okay, so x to the 4. Does it make sense?
Mm-hmm.
Okay, plus, what would I have here? I would have 5x. Okay, what does the rule say? 2 minus 5. Okay, do you agree if the 5 is here, you subtract? Okay, so what's 2 minus 5?
Minus 3.
Okay. Can I integrate that now?
Yeah.
Yes. Okay, why? Because this is in the right format, and so is that. Okay, so let's integrate that. That would be what? X to the 4 plus 1 over 4 plus 1. Okay, that's the first one. Plus this. Okay, so integrate that. Well, if I have a positive and I'm integrating, I'm going to write down the number. I'm going to write down the x minus 3 plus 1 all over minus 3 plus 1. Okay, now the last step is just to simplify. Yes, what do you get if you simplify that?
It's just a city power thing.
No, it's Nikkei 911.
Oh, that one. I thought it was this white truck going past me. Like,
Okay.
yeah.
So if we simplify, the final answer would be what? X to the 5 over 5 plus. Okay, so here I can simplify. Don't write down the plus. It's a minus. Okay, why? Because you've got 5 over minus 4. 5 over minus 4 is minus 5 over 4, or 5x to the 4, x to the minus 4 over 4. Oh, hold on. My adding is bad. Sure. Made a mistake. Minus 3 plus 1 is not minus 4. Minus 2. Okay, so this, can you write this in a better format? Yes, you can. Okay, so x to the 5 over 5 minus 5 over 2x squared plus c. There's it. And that's the same as what they've got. Yeah, 2x squared plus c.
Yeah.
Makes sense?
Yeah.
Okay. Alright, so the next thing which we need to look at is separate to what we have here. It's just a note about finding the arbitrary constant. Okay, so you can write a heading for this. Okay, that's all the derivatives. That was just something additional. What must we remember? Simplify. Get it in a format that you can actually integrate. Okay, so heading for this, finding the arbitrary constant. Okay, i.e. finding the C. That C,
that means arbitrary constant.
Yeah, arbitrary meaning it could be anything. Okay.
Let's just see this.
Okay, so how do we find the arbitrary constant? Well, actually quite easily. We just need a point. Okay, so let's do this example. You can say e.g. We'll write steps as we go.
Okay, cool. Okay.
Okay, so the example, e.g. solve dy over dx equals.
Solve
dy over dx equals 3x squared minus 5.
3x squared
minus 5.
Minus 5 is the constant, or?
Yeah, as a minus 5 separate here. Okay. Given that the curve passes through point 2, 4. Okay, so in other words 2, 4. X is 2, y is 4. Passes through the point. Okay, the point, use the bracket 2, 4. 2 as x and then comma y as 4.
2 and 4.
Exactly. Okay, so see, they have to tell you something about the function. Okay, because what is it? It's a function.
Yeah.
But that function can be drawn on a Cartesian plane and you could actually visualize what that actually looks like. Okay, we don't have to do that. We're just looking at the integration. Okay, so step 1, you can write that down. Step 1, integrate. Get the function basically. And you have the derivative if you want the function. Okay, so you do that. Let's see if you can get there.
So step 1, integrate.
Yeah, step 1, integrate, because they gave you dy over dx. So you need to get back to the function. Okay, if you've got dy dx, you've got y equal to something.
So this is the derivative.
Yeah, something else to note here, just to add to this diagram, this picture. What could you write here as the y? Oh, I get the answer. Okay, what could you write this as? It's y equals. See that? Y equals. Y equals. Y equals. Okay, because you had dy over dx. Okay, but yeah, that you can write down just now. Okay, so what do we have as the function to integrate?
Okay, so integrate.
Yeah, so 3x squared minus 5 is going to be what?
Two times 3 is 6, so it's 6x, so it's 6x. Because 2 times 3 is 6, and
okay.
2 minus 1 is 1.
What are you doing? You're doing the derivative. You're not integrating.
Oh, sorry.
You did the wrong one. Okay, you are finding the derivative of a derivative. That's the second derivative.
Okay, never mind.
Okay, so what do we want? We want the...
Oh, so the other formula.
We want, yeah, integrate. So that you would write this like that. This is what you would write. Equals. Okay, so if I've got a -5 here, because it's a -5 and it's part of the expression, okay, we need to integrate it. Okay, so what are we going to do? We're going to put a -5x here, because do you agree, what is the derivative of -5x?
-5.
Yes, exactly. Okay, so when you have this as part of the integration, you just need to write that down. Okay, because it's part of the integration. Right, because you know if you have one
Can
extra
I write
chocolate,
it next to you?
so you would write it down as is, yeah, like that. Okay, so what is the final answer? Well, in terms of the function, that's the function. Okay, so what is this function? Well, this was dy over dx, right? So if it's dy over dx, this is the function for y. There's it there. Okay, then what else do I have? I have a point 2 and 4. Right, so is it possible to find c if I know what the point is?
Yeah.
How do you do that? Substitute in, do you agree?
Mm.
Substitute your 2 in for x. And substitute your 4 in for y. And you should get it. Okay, so let's see what c you get. Oh, did you finish all those exercises from last week?
Yeah, I did that.
Okay, perfect.
I batted with the derivatives though, I don't know.
Okay, it's fine, we'll look at it.
But I think if I try redo them now, oh no.
It's fine, don't worry.
Just because it had a...
Let's finish this first and then we can look at it.
I don't really remember.
Substituting in, hey? Okay. Right, so carry on with the substitution. You can check it yourself.
Okay, 6 equals C.
C equals 6 is correct. Good. Or 6 equals C, same thing. Right, so is it possible now to write down the function? Yeah, so the final answer would be this. Y equals x to the 3 minus 5x plus 6. Because now you know what the C is. And that's the final answer. Okay.
Yeah.
Right, we've got 2 more things to cover, just application for this, and then we're done with the section. Okay, so the next point is just looking at when you have a definite integral. Right, so I'm going to take one of the examples. Let's actually take this one that we've got here. And we'll write it down. Okay, so this is integrate 3x to the squared minus 5dx. So what happens if I have this? You can put a little heading here. Did you label these 1, 2, 3?
No.
You didn't. Okay, so then this would have been 3 if you labeled it, but it's fine. You just call it definite integrals. If something is definite, what does that mean?
It has a value.
Exactly. Okay, you know what it is. It's definite. Okay, so that's exactly what we're doing here. Okay, so all I'm going to do is I'm going to write down what I wrote down here. What is it? 3x squared minus 5. Okay, dx. Right, and definite integrals have a 1 here. Alright, to something. It doesn't have to have a 1, it could be any number. It could be 2 to something. I'm going to use this one, 2 to 3. Okay, so this is the definite integral. This little bit over here. Okay, when you have numbers there, that refers to a definite integral. Alright, so that's the heading for this one. Definite integrals, you have the notation.
How do you spell integrals?
I-N-T-E-G-R-A-L. G-R-A-L-S, integrals. Okay. Right, so this is a definite integral only because of that 1 and the 3. Okay, and it's actually quite easy. You can see our filters. It's literally like 2 lines here in the textbook or work program. Okay, so all you have to do is do what? This. Right, so do you still do the normal integration? Yes. Okay, so remember, you get from there to this. Okay, we did it already, so we don't have to redo it. Okay, what was our integral? There's it. Our integral is y equals x to the 3 minus 5x plus c. X to the 3 minus 5x plus c. Okay, when you have a definite integral, you've got to add this. A bracket like that. And you're looking at 1 to 3. Okay, that's what you're doing. Okay, so the only reason why this is called a definite integral is because you definitely know that there is a 1 to a 3, and that's the room that you're looking at. That's the space that you're looking at. Okay, so what do we do on the next step? Well, the next step is you substitute this in.
So do you write it like this?
Yes, exactly as I'm writing it, you write it as is. And you substitute that in. Okay, and it's the bigger number minus the smaller number. Okay, that's the next step. Okay, so the next step would be equal. So all of that square bracket with the 1 to the 3 is going to equal, open brackets, what's 3 squared? Well, 3 to the 3 minus 5 times 3 plus c, close that bracket, minus, open up another bracket, 1 to the 3 minus 5 times 1 plus c. Okay, that's what that means. Okay, so this step number 1, just do the normal integration. Step number 2, the 1 minus the big number, the number at the top minus the number at the bottom. Okay, can we solve that? Yes, we can. Okay, so 3 to the 3. 3 times 3 is 9. 9 times 3 is 27. Minus 5 times 3 is 15. Plus C. Okay, then we've got a negative here. A negative times all of these. Okay, so 1 to the 3 is 1. Minus 1. Okay, minus 5 times 1 is minus 5. Minus times a minus is plus 5. Minus times a plus C is a minus C. Okay, so can I simplify that? Yes, I can. Do you agree? Here's a plus C and a minus C. So when you have a definite integral, those C's always cancel out. They have to. If they don't, then you've made a mistake somewhere. Okay, so this you have to type into the calculator.
So you have to have a minus C and a plus C.
Yeah, because you're multiplying out the negative.
So will you always have plus C minus C?
You'll always have, yeah, it'll always cancel out. If it doesn't cancel out, you made a mistake. Okay, so what do we get? Let's see. I'll quickly check it for us. 27 minus 15 minus 1.
Where do you see minus 1? Oh, really hard to know. Plus E minus 1. Plus 5 there. 16.
Okay, there's the answer. Right, so now you know what the definite integral is equal to. Okay. Happy with that? Okay, perfect. And then the last bit is just this, which is I've got notes for it. Here's the last bit, these 2 slides. Okay, this you can maybe write, I don't know if you'll fit it in. I think maybe start on a new page because it's a slightly different, it's the last bit of this. Okay, area under a curve. Okay, so there's 4 things that we looked at today. One is the ordinary, okay, just ordinary integration. The second one was when we had a bigger expression that we had to simplify. 3 was this, the definite integral, and then 4 is just the application, area under a curve.
Okay.
Okay, that's the last bit. This is this bit over here. Okay, so the heading for this, area under the curve.
Can I answer the last one?
Sure, no problem. So this is the last bit in terms of the application, area under the curve. Okay, so what do we know in terms of integration? What does it do? It gives us a function, right, when I've got a derivative. Okay, so earlier we spoke about a definite integral. Right, is this a definite integral? Yes. Why? Because you've got 1, 2, 3. Okay, and this is the derivative. Right, so what must we first do? We first need to integrate. There's the first step. Okay, integrate. So do the whole process. Do that, and you're left with this. See, that's the integration. Right, so what does the integration do? It gives us the function. Okay, once I've got a function, what does this function give me? It gives me points on the actual graph. So if you're looking at from 1 to 3, if A is the 1 and B is the 3, okay, you're looking at from one point to another, right? And what integration does is it gives us the area under the graph. Okay, so this bit over here can be calculated using the integration. Okay, that's what it does. But all I need to do is just find the definite integral for this term. So what am I going to do here? Put a bracket, and I'm going to solve for 1 to 3. And what I do, I substitute the 3 in, and I minus the substituting in the 1. Okay, and that's what I've done on the side. Okay, so what do? I take the function. Okay, I substitute f of 3. Put the 3 in. Okay, if I put the 3 in, what do I get? 3 squared over 2 plus 2 times 3. Right, if you work that out, you get 10.5. Right, same thing with the 1. Substitute the 1 into that. Okay, 1 squared over 2 plus 2 times 1 gives you 2.5. Right, then what do? You take the 1, you subtract the other. Right, so this minus that. 10.5 minus 2.5 is 8. Plus c minus c is 0. Okay, so what is the area under the graph? The area under the graph would be from 1 to 3 would be 8. Okay, 8 units, 8 measurements, okay, of that. And that's what you're doing here. Okay, so area under the curve. Right, the same thing applies here. They've just drawn a diagram. See? Area under the curve. They've highlighted as well in the work program. Okay, so let's do this one as another example, because I'll send you these slides so you have it. Let's do this one. Okay, so you can say area under the curve. You can put a bullet. Calculated using the definite integral. That's how you find the area under the curve. Found using the definite, or calculated using the definite integral. Okay, the definite integral, because you've clearly got one point as a starting point and another point as the ending point. Can you have negative area? No, you can't. Okay, so another point, area is always positive. Okay, that's self-explanatory. Okay, area must be positive. You can't have negative area. What would that be? That would be very weird. Okay. Right, so let's use this as an example just to practice the integration. Okay, I'm going to give you the question as they've stated it here. So example e.g. Find the area between find the area between point x equals 0 and x equals 2. Find the area between x equals 0 and x equals 2. Given y equals x squared minus 4x. Okay, so that's the question. X squared minus 4x. Right, so how do I find the area between 2 points? I write down the definite integral. Okay, so you would write down, I'm just going to write down the question here, just so you can see what it looks like.
So step 1, find definite integral.
Yes, okay, so we'll write down the equation for it. So that's what we're doing. Okay, so f of 0 to 2, can we read the question? Now we're writing it down in mathematics. X squared minus 4x dx. Okay, that's what you would write. Okay, that's going to give you the area. Okay, so write that down. 0 to 2 of the integral, x squared minus 4x dx. That's what we need to do to get the area. Yes, let's apply the definite integral to this question. Right, what would we have as a definite integral? Well, we first need to integrate. Right, so that I want you to try. Let's see if you get it right. Integrate this. Apply the rule. Yeah, there's it. All there. Yeah, so draw a big bracket or a big square. Now, what is the integral? We need to work that out. You need to integrate. Integrate.
Oh, first integrate. Okay, so
So it'll be 2 plus 1 over 2 plus 1.
Yeah, because we had already found the integration for this, hey?
X to the 2 plus 1 over 2 plus 1. Minus 4x, so minus 4 x to the 1 plus 1 over 1 plus 1 plus c. Okay, simplify that.
So we're first finding the what differentiation?
We're integrating. we're finding the integral, and then we're going to get the definite integral. Okay, so they gave you an expression that needed to be integrated because that's how you find the area under the curve. Okay, what points from 0 to 2? From 0 to 2. Right, now we can see the substitutes. Okay, that you should be able to do. Okay, so what do? Substitute the 2 in, and then minus substituting the 0 in. Let's see what you get.
So it'll be 0 and 2, yeah?
Yeah, it would be 0 and 2. That would be the area under the graph. Okay, the graph might not look the same as the example that I did here earlier.
Yeah, it's okay.
Okay, but you can see it actually looks like this. That's what it looks like actually. See that? Okay, it's a parabola. Yeah, but the concept is still the same. You work out the area.
Okay, so now this is the equation. So the first bracket we're subbing
2
in the
minus second bracket subbing 0. Yes. Okay, good.
So it's 2 cubed over 3 minus 2 squared plus c.
Close that bracket.
Minus.
Bracket put in zeros.
Okay. 0 cubed over 3 minus 2 0 squared plus c.
Okay, good. Last line, next line, equals. Yeah, that you can use the calculator. Don't worry about having to do it manually.
3 minus 2 squared minus 16 over 3 plus c. Plus minus c. So the answer is minus 16 over 3.
Correct. Good. Right, so once you've done that, minus 16 over 3 is the answer. But is that the answer?
No.
Why? Area is always positive.
Okay.
Okay, so then the answer would just be 16 over 3 because the area must be positive. Okay, so just remember that whatever you get, just make it a positive. Why? Because you can't have negative area. Area is positive.
So then it'll be 3 over 16.
No, 16 over 3. You literally just make it positive. 16 over 3. Okay. And that's it. That covers that section.